This is video 1 of basic trig identities, and we're going to start with this drill, and you are encouraged to do this drill without using a calculator. You want to get used to being able to just sketch a quick unit circle, and then I always label my unit circle. Remember that this is the origin on the coordinate plane, and this is 1 unit over, so it's 1, 0. This is 1 unit up, 0, 1, 1 unit to the left, that would be -1, 0, 1 unit down is 0, -1. Then I go ahead and I write in my degrees, 0, 90, 180, 270, and back to 360. It's also helpful if we note what our radians would be at this point. So I would have 0, and remember this is pi, and so this is half of a pi, and down here is 1½ pi, or 3/2 pi. When I come back to here, I'm at 2 pi. So I call this the 4 corners of the unit circle, and you want to be starting to memorize those 4 corners. So 0 degrees in radians is simply 0, and then I can just look at this unit circle that I've sketched. 90 degrees is my pi over 2, 180 is pi, 270 is 3 pi over 2, and 360 is 2 pi. Then sine. I have to remember that sine is the y coordinate. And so just simply looking at my y, it's 0. Go to my next y is 1. At 180, the y coordinate is 0. At 270, the y coordinate is -1. And at 360, the y coordinate is 0. Next, I'm going to do cosine, which is my x coordinate. So at 0, I'm at 1. At 90, I'm at 0. At 180, my x coordinate is -1. 270, my x coordinate is 0. And back at 360, my x coordinate is 1. And then my tangent is sine over cosine, which is y divided by x. So I'm going to look here. 0 divided by 1 is 0. 1 divided by 0 is undefined. 0 divided by -1 is 0. -1 divided by 0 is undefined, and 0 divided by 1 is 0. Now that we've finished the drill, I'm actually just going to turn this page over, which gives me a blank page to take some notes on. We're going to be filling up this page with 4 separate theorems. These theorems are not theorems that you have to memorize the names of them, but you have to understand the concepts. These 4 theorems are the basis of really this entire unit and questions that you're going to be asked. You're going to see we're going to spend a lot of time in this section. All right, the first theorem we have is called the Opposites Theorem. Okay. And I'm going to draw a sketch of my unit circle. And in my sketch, I'm going to realize that in this first quadrant, cosine and sine are going to both be positive because this is my positive. And when I divide, I get a positive. So this stands for this is simply looking at the x-axis is positive, the y-axis is positive. So it's the plus plus quadrant. And when I'm looking at my trig identities, this is cosine, this is sine, and this would be tangent, because tangent is sine over cosine. This quadrant is negative and then positive, because x is negative, y is positive. When I divide, I get a negative. So cosine, sine, tangent. This quadrant down here, my third quadrant, is negative, negative, because x is negative and y is negative. And my tangent then ends up being positive. This is my fourth quadrant. X is positive, y is negative. When I divide, I get a negative. So I'm going to draw that. And this theorem, I'm going to leave a little space here because we're going to write something else here. But the theorem says that for all theta, cosine of the opposite of theta equals, well, let's think about this. If theta is in the first quadrant, and then I go the opposite direction, like let's say I said 20 degrees or negative 20. I'm either in quadrant 1 or 4. Well, look at cosine. It's positive in quadrant 1 and it's positive in quadrant 4. So it didn't change. Let's try it this way. What if I said cosine was 120? Ooh, then it's negative. What if I said cosine was negative 120? It's still negative. So the cosine of the opposite of theta, meaning going the opposite direction, is the same as going the positive direction. It doesn't matter if I go to the first quadrant or the fourth, which would be the opposite direction. Cosine stays positive. If I'm at negative 120, positive 120 or negative 120 degrees, cosine is negative either way. Now let's look at what happens with sine. Sine, if I'm in the first quadrant, let's say at 30 degrees, sine is positive. If I go negative 30 degrees, the sine becomes negative. It changed signs. So we say it's the opposite of the sine of positive theta. Let's look at it this way. What if it was 120 degrees? The sine is positive. If I go negative 120 degrees, the sine is negative. So here it's positive and here it's negative. Tangent of the opposite of theta. Let's see what happens there. Tangent in the first quadrant is positive. If I go the opposite direction into the fourth quadrant, my tangent is negative. So the tangent, the sine of the tangent, meaning the SIGN, changed. Okay. Now, I don't know if you noticed this, but when I went to, let's say, 20 versus negative 1, 20 versus negative 20, or 120 versus negative 120, I always end up in quadrants that are above and below. So we are looking at quadrants in same half, above and below each other. That's what we are looking at when we look at the opposite. Because 50 degrees, negative 50. Notice they're in quadrants above and below. 95 versus negative 95. Above and below one another. So in the opposites theorem, we're looking above and below. And the cosine stays the same, because look at cosine above and below, plus, plus. But look at sine, plus, minus, and look at tangent, plus, minus. Come over here to this side. We look at cosine. Negative, negative. Cosine stays the same. And then for sine, plus, minus. Sine changed. Tangent changed in quadrants above and below each other. That's my opposites theorem. Cosine stays the same, above and below, sine and tangent change. Right. Then we're going to look at what we call the supplements theorem. Okay. We're going to do the same thing. We're going to draw this circle because you have got to get really good at knowing this. This is plus plus, which makes this positive. This is negative positive. X is negative. Y is positive. So this is negative, negative, negative. When you divide, you get a positive, positive, negative, which gives you a negative. Okay? The supplements theorem say that angles add up to 180 degrees. You should have learned that in geometry, that supplements add up to 180, or pi, because pi is the radian equivalent of 180. So we are looking at quadrants that are not above and below, but they are side by side. That's what we're looking at. Because, for instance, if I'm in quadrant 1, 20 degrees here and 160 degrees here, they're both 20 degrees off of the, everything we do, by the way, is measured from the x-axis. This is 20 degrees up, this is 20 degrees up. 20 and 160 adds to 180. So that's what we're looking at, angles that are supplements of one another. So for all theta, the sine of theta, pi minus theta equals, well, let's look. So if we're looking at sine, so the sine in side-by-side quadrants, this right here means side-by-side. That's what you have to remember. You have to remember up here that this means above and below. This right here is going to be side-by-side quadrants. The sine in side-by-side quadrants, you have the y-coordinate is plus, the y-coordinate is plus. It stays the same. Let's look at cosine. Okay, go in side-by-side quadrants. In side-by-side quadrants, cosine, here is positive, here it's negative. It changed. Let's go down here to these side-by-side quadrants. Positive, negative, it changed. So it is the opposite. The sign changes. When I say the sign, I mean the S-I-G-N. Right? And then let's look at tangent in side-by-side quadrants. That's what this means. This right here means side-by-side quadrants. So in my side-by-side quadrants, look at tangent. Plus, minus, minus, plus, it changes. So it's the opposite. If one is positive, the other is negative. Okay? Then we have what's called our half-turn theorem. And that's when we're going to move halfway around the circle so you add 180 degrees or pi. The quadrant